Okay, cool.
All right, let's go ahead and get started for today.
I want to know now.
We're recording today. I know there were a couple of questions about that because Macy can't be here. She, in general, won't be able to be here on Wednesdays because we just couldn't make her schedule work out. She's doing kind of like Braden did last year. So we're actually going to videotape. We're going to try to videotape it, at least see if that works. Today's assignment. Oh, I know a couple of announcements too. A couple quick announcements. There will be study hall tomorrow if you're in study hall. Okay. Because originally I was going to cancel it because I was supposed to do some training over at Central, like at that time, but it's gotten moved to 1 o'clock. So yeah.
What's the time for study hall?
11:40 to 12:45ish. Yeah. And so, okay. So unless you have, if you're in the study hall, you've got an email message from me about that, and unless you're in an IT Tech class at that time, you should be there. Okay. So we will have study hall on tomorrow because I got moved to 1 o'clock for my training over at Central. I get there in 5 minutes. No big deal. All right. Second thing, I think everybody in this room, your schedules are now under control. All right. I know there were a handful of people who, like, a class got canceled at Ivy Tech or something like that. I think everybody in this room, you're under control. But if you're not, let me know. Included in the ways that things might not be under control is about your bill for gens. Okay, I know that the seniors, well, that's it. Some people have looked at their bill on the Ivy Tech invoices or whatever, and okay, you do pay for gens, but it's not like a full tuition type thing. Okay, it should be like $50 or something like that. Okay, and like it doesn't have to be like by the end of the street kind of thing. The business office, as long as you're in good standing with them, if you make a second payment in February, they don't care, that kind of thing. Okay, but anyway, the point is, if you're a senior and you're in gens, check your bill. You might have been billed 170, I think, was the base rate for gens, and so I think people got billed up, but it should be like 52 or something. All right. If you got that wrong, it's not the end of the world. You and me, or you and Mr. Punky, just walk over to the business office. There's a form we sign that you were supposed to get the reduced tuition. They click, and it happens. Okay, and you pay the bill the next day. I think it takes 24 hours to get processed or something. All right, so if you're a senior and you're in gens, check on that, okay? Because I know there were a couple of mistakes where people didn't check it and they had it set up as automatic payments. And so they just got, it was wrong and the money just came out of their parents' account. And it's not the end of the world, we can get it fixed, but let's just prevent problems. If going over there and we sign an initial on a form and they bill you the right amount, let's do that. Okay, so if you have your schedule under control and you know about this gens thing and you can at least check it and all that kind of stuff, that's good. Okay, I'm guessing the last assignment was both familiar and a little scary, right? Because on one hand, a lot of it was just the same things we did back. We did polynomials and rational functions and quadratic functions and all that kind of stuff. And we were just describing functions in terms of things like their intercepts and their domain and their range and so on. It was just a new thing. It was graphs of things like sines and cosines. But once we had them, it wasn't really that big of a deal. I mean, if I just go into Desmos here real quick and start graphing, I mean, we had functions that were our parent functions. Again, the word parent function isn't something I love. But here's the parent function for sine, where, then we can do things to modify it or transform it. We can vertically shift it. We can do the phase shift of it. We can change its period. We can change its amplitude. And we can use that to model something real. You did that on the exit ticket the other day, where you were modeling with an equation how somebody was breathing. The function was the velocity of air going in and out of their lungs, and with a little bit of adjusting of the period of the function and its amplitude or something like that, you were able to model, to create a mathematical representation of how they were breathing. And the same kind of thing can be for temperature. It gets warmer, it gets colder, it gets warmer, it gets colder. It can be sound waves, where you're talking about the pressures, the little waves going past your ears right now. It can be anything that's an oscillatory periodic type behavior like that. And we're going to have lots of interesting examples of it. In the last lecture, we did sine and cosine. Because these little guys are just little wavy things. Today, they want to bring into the same kind of discussion, doing the same things but just for the other functions, like tangent of x. Holy cow, he's a weird one. Tangent of x is it a function? Sure, it's a function. It's got, it passes a vertical line test. You might not be able to tell immediately by looking at this, but it passes a vertical line test. Meaning any given place along the way, a vertical line only crosses it at most once. It sure looks weird, but when you think about what tangent is, where tangent of x is the same thing as sine of x over cosine of x, you can see that there's a problem here. If you've got in the denominator cosine, cosine can be 0. There are values of x for which cosine of x is 0, which means this whole thing blows up. Right? So like if I actually, well, for that matter, I could do it. I could put on the same graph here. Let's make a graph of cosine of x. And what you see is there's places where cosine of x is equal to 0, like negative pi over 2, or let's do it over here, how about this one here, pi over 2. At pi over 2, the cosine is 0, so you're dividing by 0, no wonder tangent blows up. But really, other than the fact it's weird looking, it's the same kind of thing as sine and cosine. It's a periodic function that repeats. Let's see, how often does it repeat? What is its period? If we look over here on the x-axis here, we see that it crossed here at 0, and it crossed here at pi, and it crossed here at 2 pi. See how its period is pi? It just keeps repeating every, so whatever you get here, this value of x plus pi, it'll be the same. This one plus 2 pi, it'll be the same, and so on. It just keeps repeating. I mean, other than that, we could talk about the domain of this function. It's pretty much negative infinity to infinity. But there are some values of x that don't work. Those ones where cosine of x is equal to 0, and the whole damn thing blows up. But the domain is basically negative infinity to infinity, except those places. And your book will show you, oh my gosh, did I just say something like the book is going to show you? Yes. Where those places are. They're going to be at like pi over 2 and 3 pi over 2 and so on. And what about some of those other friends of ours? Let's see, what other ones did we have? How about cotangent, COT, sure, what the hell? Hey, it looks kind of the same thing. It just goes the other way.
Yo.
Yeah!
It's just the cotangent.
Cotangent. Alright. But other than that, it looks like it's the same thing. Alright? It just reflected the other way. Hey, how about what we got? Secant? Whoa! Secant! It's the same kind of thing, except now it's weird little cups and hills or whatever, valleys and hills. But again, it's still a periodic function. It has a domain. It has a range. Whatever. Okay, for that matter, wait a minute, there was a sixth one, cosecant. Here, I'll put them on the same graph. Ooh, it gets crispy. It looks like wrapping paper. It's the same sort of thing. So tangent and cotangent are those wiggly lines. It's just tangents, they wiggle off to, like, if you think of it as a map, they wiggle off to like the northeast. And on cotangent, they wiggle down to like the southeast. And these guys are just like alternating cups and hills or whatever, valleys and hills or whatever. But you know what? You're going to get really fluent at this because you're going to do an assignment that does the same kinds of things you did for the sine and the cosine ones, except now you're doing this. And all these functions can be transformed, just like you did for sine and cosine. I mean, if I made just a simpler one here, let's do tangent. I'm going to zoom in a little bit. I'll just hit the home button so I get back there. I mean, all that crap we did of a plus b, you know, we could do a plus, no, sorry, it was d plus a tangent b x minus c. But we're going to have to actually put in values for these guys. So like, I could make the amplitude of the function bigger or smaller. I could make the vertical offset bigger or smaller. I could adjust the period of these things. Or I could do, which one is the offset? This one. I could move adjust the offset. Just like I did when these were sine and sine. Just like I did before. Let's switch this thing back here. We'll put this amplitude back here. Alright, now let's put this thing back at 0. And put this thing back at 0. Okay? So when I had my parent function, I could do a vertical shift by changing the value of d. I could do a phase shift by changing the value of the c. I could change the amplitude by changing the value of a, including changing it to a negative number and flipping it. Or I could change the period of the function, like the wavelength, if you will. It's all cool. Today you're just doing the same thing that you did on the last assignment, but for sine, that you did for sine and cosine, you're just doing the other trig functions. I'm pretty confident you're going to be fine with this. So here's my lesson plan. I literally wrote nothing. Because I'm pretty sure that you're going to be just fine doing the same thing you've been doing. And it's just for the new ones. It's some plotting in Desmos. It's some getting more fluent with these things. I don't think you need a big lecture to make that happen.
You might be correct.
I might be wrong.
Maybe.
I might be. Anyway, so we're good on that. There is an exit ticket, but for some reason there's a network problem. It did not yet post, so I will, once you guys get this all written down, I will see if I can get the yeah.
We need 5 E's. Skip them.
Skip them.
Skip, yeah.
Well, wasn't there a 5E and a 5C? D?
Oh, on the question.
Yeah. There's so number 5 and number 7 have a part E. So if you look at 5, I think it has like 6 parts or something. Skip those 2 parts.
He just needs the parts.
Yeah, there's parts. I don't remember what 5E and 5 said. So there are all these pieces. Yeah, just don't do the E part, but this one and this one. Okay. So I'll wait till everybody gets that written down, and then I'll fix the extra ticket. I'm going to go ahead and turn off the camera. We don't need to be recording all this wisdom.